Hello class, this is your instructor Pranati Anamala, and this is a recording about association rules and a little insights into assignment 4. So we read in module 4 about association rules. So I just wanted to give you an overview about this because you've already gone through, I hope you have gone through the slides and you have a little idea of what is association rules. How so in this assignment what we're going to do is we're going to run text analysis using this data mining technique. So association rules is basically finding frequent connections between two or more items, and then you could think of this as a shopping basket. And further, we're going to do this using Rapidminer. And a little additional to what you see on these slides, I just wanted to mention one more important concept, which is actually involved in association rules. The author talks about a priori algorithm. This is all about it: confidence, premise, and conclusion, support. I think he doesn't, or he does. Well, it looks like he doesn't have it here, but association rules use the a priori algorithm. That is the algorithm which contains the methodology that's involved in finding frequent patterns in a set of items. So let me quickly share you that. I'm going to post this article on Canvas. So it's not a mandatory read, it's a fun read. So if you want to really know what's happening inside besides using the association rules, you can do this. So this is an article which talks about improvised a priori algorithm, but I think this is enough to follow what exactly is happening in there. And we're going to follow. So the assignment is a repetition of this process, but then not anything to do with code, but it's just a process that will help you understand the association rules without actually having to code. So partition the cluster into groups. So remember this into groups, because don't pay a lot of attention to like K, because you might get confused with K means clustering. So for this part, we're just think about this one as just like tokenizing the terms and then generating the items with unique IDs. And then what is the finding the frequent items like by set, and then trying to if you read the association rules like process for it carefully, you'll notice that we are looking for minimum support, the values of minimum support, and the value of minimum confidence. So with that being said, I think the author from the textbook also explains about association rules a little bit more with the support and confidence, which I think it was helpful to understand initially if you have no idea what's happening. Frequency, yeah, confidence percent and confidence support percent. See how confident we are when one attribute is flagged true and the other one is also as true. So while we do this process, I'll tell you towards the end when we see the results, like how could you actually interpret it. And the support is how many times that rule did occur divided the number of observations. So these two values, like although they seem that it's something that you would see towards the end, but in our process we're going to give these up front. When we have a data set, we're going to tell the algorithm that, hey, this is what I want to find out. Maybe with 50% confidence and 10% support, I want to find what is happening in my data set. So you have further examples to understand what is confidence and support. So with that being said, I think I want to move to Rapidminer. Great. All right, so the first step would be, okay, since I already have the extensions, I'm just going to show it to you, but this is, if you're doing this for the first time, you might want to check if you have the text processing. So basically, assignment 4 and 5 are going, and also your final project, be more into text mining. So look for the text processing extension. So since I already have it, and then it says package up to date, that means that it's already installed. But something like Python scripting that I don't have, I'll have a button which says select for installation, and the button goes like green for me to install it. So make sure you have admin access to the computer on which you're running Rapidminer. And also, I think the online, the remote connection to lab. So I've given that link in the syllabus. If you're unable to install it on your machine, you can always remote desktop to one of the computers in Discovery Park Lab B205 and use Rapidminer in it. So once you have installed this and you're ready, you're all set. So the first step would be to import data. So I'm going to use a data set which is similar to what I have posted on Canvas. It would be the employee reviews on a set of companies. I'll click on import data and go to my computer, go downloads, because I think I have it in downloads. It's taking a while. Let me go and select Microsoft and click next. And it seems to load most of them, and I'll click on next, and then yeah, identify the header. So here you'll notice that each of this column data type is a little messed up, except for the date and some integer values. So only one column has integer. So what I would suggest is all those ones that you think should be text, you can leave them, and because when we click on this button here, it does give us the opportunity to change it, but the problem with the text is it's not listed here. It's a bug that their Rapidminer is trying to fix. So I would say the others, you can change it to integer, and then you could notice that none will go to like a data mismatch, but we can address that using missing values. So try to do this. This is just getting a quick hands-on on changing the data type to integer. This is already integer. And then when you see there are errors because of missing values, it doesn't let us go to the next step. So just click on ignore errors, and then it just leaves us out with warnings. Click on next, and I want to save it on my computer, so I'll put it in the local repository and under the folder data where I have all my data files. So I'll leave the name as data Microsoft 3, or you can always rename it, and click on finish. Yes, you can see it's loaded, and it has 4,500 records, that means rows, and then 17 columns. Then I'll go back to design, and I can see data listed, Microsoft data listed under my list of data sets. Then right click on it and click on edit, because remember I have to change this to a text data type because I want to process the text value. So I'm going to right click on the particular column and click on modify attribute, and then select text under attribute type and click on apply. I'm going to repeat this step to most of the columns here. I'm trying to do it quickly. You can rewatch this video or follow along. Text summary, text cons, text. And then I want advice to management, so to be text. And I want the link to be text. Well, you can always choose to change only the ones you want to use for your analysis, but I just did it for everything because I just want to be safe. No matter, I don't have to go back to this step multiple times if I want to do this again. So once I've changed everything, just make sure you save it. Click on the save button, because if you don't save it, none of these will reflect in your data. And another important aspect you have to remember is you have to make all those changes before you import your data to your canvas, because if you make any changes to this after you import it, this particular file is not affected by what you change here because you've already imported here. So if you make any changes here, make sure you delete this file, delete this operator, and then try to import it again once you've saved this one in the data editor. Just remember that's it. Most times students forget that. So I just want to make sure, because you ultimately, when you run the process, you won't be able to see any results if you've not saved your changes in the data type. Now let me address the missing values that I have. Replace missing values in the columns. I'll connect to missing values, and I only want to filter the ones that are integer, and I want to change the missing values to zeros. This is just my choice. You're free to do. You can either delete those rows, or you can put 0, or you can put none. Either of it works. But just make sure, take an executive decision, like a smart decision on what actually helps. And I'm selecting only the integer values. You notice that the icon is different for integers, it's different for text and date. So this is my subset. This is my full, that was my full set when everything was on the left side. Then I'm just making a subset of integer values. Click on apply, and I want the default value to be 0. And let me run it and show you what happens with that. Hopefully it works. Yeah, there you go. So you don't see any question marks anymore, and it is sorted, or it is filled, addressed the missing values for me. So I'm going to close this and this, go back to my design, and you can also follow along the instructions on Canvas. I'm just going to do it really quickly here to the point where I focus on the rules and explanation for it. So I'm going to connect here, select one single attribute, which is cons, and go to process documents from data. Just remember, you'll have 2 different, so just take process documents from data, and then connect it here, and then double click on process documents from data, and first break it down like you've seen in the algorithm, tokenize to filter out all the non-letters, then make everything to lowercase. So I'll select transform case to make it to lowercase, and I will filter stop words, English stop words, and I will do filter length. I want to tokenize by length, filter tokens by length, and I will only take like anything which is below 4 characters and above, not 25, you can just maybe 30 or 35. You're at liberty to do this. Filter tokens by length is just going to take off all those words which have less than 4 characters, And there's another feature that you can use, but the assignment not necessarily asks for it. It's filter tokens by content. What this operator does is it takes it takes the records or the data, the documents which contain this particular string. So I like when I'm trying to when I know that for a fact that I'm talking about Microsoft or something like COVID-19, COVID, just COVID in general, and I'm sure, like I'm 100% sure that the articles that I extracted will contain COVID, the word COVID. So what I could do is that I could click on invert condition and maybe filter out all those tokens tokens called COVID, because the problem is when I do a word cloud or I try to do a frequency count, the word COVID is bound to happen or appear a lot of times than other terms. So this actually hinders our analysis a little bit, where you're having to decide, okay, what is the next best term? Because I already know that my articles are about COVID. So that's something you want to think about. If you think it's appropriate, or you find a term which is like it's occurring too many times, that's not really helpful, you can use the filter tokens by content, and then to remove it, invert condition. To include it, you just include it, just have it that way. You have other options as well here. So for the assignment, we're just going to take this off and put it back here. I will click on process to go back to my process, and okay, now I have all my words with that. So I'm going to convert them to where I have words and their frequencies. So for this one is numerical to binomial, where I'm keeping the numbers and I'm also keeping the words. So binomial is numbers and characters. So since I've already filtered here in select attributes, I'm not gonna filter anything. I'm just gonna keep it all. And minimum, maximum, I think I'll leave it to that. I think, let me double check. Okay. Yeah, I don't think I changed anything here. And then I will do my operator FP growth, which is FP stands for frequency patterns. So I'm taking the words and the numbers to the part where I'm counting their frequencies, and this is where the requirement support comes in. So let's start with 5% of support. And then item set, I usually don't change any of these. And then I'll go on to my final operator, which is create association rules. Say I think it's frequencies to ITE. And then the rules and also the items if you want. If you hover over the operator, it gives you what exactly is the output going to be. So, and you can see that the metadata is frequency item sets. On the first one, it's metadata is the association rules. So the rules itself are the ones that we're having output. So you can play around with this. It's pretty intuitive using this particular software. Then it gets complicated if you have to. Well, if you like coding, that's where you can write an algorithm yourself, but if you're using this tool, just play around to see what it does and then what each like click or each button means. In the association, remember, we're going back to the minimum confidence. So I want to see maybe, instead of 80%, I want to see 30%. So my criteria is confidence. So I think I have everything here. So I'm going to execute this and see if I get any results. So if you run into a problem or you don't get any results, that means one of the operators has any problem, and then maybe you have not set the vector right, or maybe you've not set the data type right, or it's just that your data doesn't have any rules with that criteria. So so that means that it did not really find any association with the criteria that you gave. So this is my frequency items output, and this is my association rules output. So let me click on description to see. Well, here's a list of like all these the support. I think I put 3% support, but then it looks like there's like 5 to 6% of support here, and the confidence is pretty good. I think it's a lot, 99% confidence. So let's lower the criteria a little more and see what else does it do. And I'll click on description to see what it does, like how it shows in the textbook. The items on your left of the arrow are the premise, and on the ones on the right are the conclusion. That means, for example, we have like life balance and work. So if the employees have written something regarding life and balance, they have written some. That means that it's associated with the word work. And if they have written time, they've written about work. If they've written work, that's always most of the time associated with life. So what can we do with these rules? So remember, let's trace back to what column did we select? We selected cons. So this is an employee reviews data set for the company Microsoft. And employee has written, or employees, 4,500 employees have written that in the cons, that about work-life balance. So in this situation, I think, well, I was a little thrown off, because why would you write about work-life balance in your cons? Because why is it? Is it because there's not a good work-life balance? But if it's or with Microsoft, it's just my opinion that shouldn't be a good work-life balance. So it's important to how you connect what column you have, or what does your column actually have, like column header, to what's inside it. Because when I did the same analysis, let me run it again with pros and see what results. Does it have the same results, or does it just different results? So towards the end, the way you interpret, like knowing your data is as important as interpreting the results, because you won't come up with the accurate solutions if you don't know what your data is about. So let's go back here to see what the descriptions are. Let's go highest. What is the highest? 75 other rules. Okay, here you can see the pros. Again, we see that it's a great work-life balance. You see that? So this is what, and with the 100% confidence, that the pros are great work-life balance. So here's, although some people have written that it's not, and then some people have written yes. So maybe you could do a combined analysis and do like a complete review, not like a broken down pros and cons. But I think when I like structuring, I like dividing it into subcategories. It helps me like understand even better, even at the most narrow level. And besides that, you can have, let me see if there's anything other that can help us understand what's going on with the reviews. So it says great, smart people. benefits more people. And then salary is good, benefits, and benefits company. It's a great company, the great environment. So I think you can pick up a lot of this stuff, a lot of these words, and then build on like a summary. So basically we have not read the 4,500 reviews, but in about probably, let's see if we can, well, I don't have it, but usually when we run the process, you can see the process time here, the results. Okay, results at 3, good, cool. So in about execution time, we can see like 0 seconds, maybe 24 seconds. Within seconds, we're able to process the 4,500 records. So you want to understand the importance of this analysis, where imagine the time it would taken for you to really read through the 4,500 and manually pick the frequent terms or maybe out of your memory. So this is doing a lot, and it's actually reducing our time or reducing our work into where we can be productive in seconds. Okay, but as data scientists or data analysts, it is our skill how good we build this model. So although we have a powerful tool to use, but it's important for us to even know what's happening inside and also be able to give accurate results. So in your report, I think, let me go back and show you something with the graph. It's kind of difficult. Maybe I'll just increase the criteria so I can have lesser values. All right, so I have work, great. I'm trying to move these weird spider things so I can see what the how are the rules associated with the words, because this particular visualization gives us a way to see like how many rules are, so I mean how many unique words do we have that are most frequent, and then the number of rules that are associated with it. So you can see it's a lot here, although I have given my criterion to like above 95%, I believe. So you can see it's a great, okay, great, work, balance, life, and good. So, or benefits. So play around with this a little bit and look at the descriptions and the data itself. See, like conclusions. Yes. So we're reading through the attributes, like the operators themselves, like these, each of these would give you a better idea what's happening within the documents themselves, and filter. So for the report, I have asked for select attributes, process documents from data, tokenize, which is inside is tokenize, transform case, filter tokens by length, and then FB growth, and then create association rules. So I would suggest reading through them in the textbook and also through Rapidminer documentation. Let me pull that up. Okay, operator reference guide. See, new share. Okay, data access, no, but modeling, associations, create association rules. There you go. So I would, if it were me, I would read through all of this to really understand what's going on and how best you can build your model, make it like super accurate. What's that? 9.7 Rapidminer. Let me see if I'm missing anything regarding with respect to the assignment, and also this. I think this is about it, and then I'll try to do the k-means clustering in the next video. I'll post it soon, and it's going to be it's similar process, but then we'll have a different parameters and also attributes to it, different operators, and then we'll learn further how we can do k-means clustering. All right, thank you so much for your time and stay safe.